Practice exam, problem 4. Given that the line integral, the path integral of the magnetic field around loop A is bigger than the path integral of the magnetic field around loop B, and they're both bigger than 0, which way do the currents flow in the wires? Well, to do this, we're going to use, this is giving us a strong hint, we're going to use Ampere's law. The integral form of Ampere's law is in a closed path, dl dot 1 over mu naught b, where mu naught is just a constant, is equal to the current enclosed, but really I'm going to write it in this form. This is d2x n hat dot j, because we need to know the direction of the current, and this n hat dot j tells us what we want to know. We know what the n hat is. The n hat will be the vector on the surface. So the n hat, here I'm curling in this direction, the n hat's actually going to point in that direction, right? Along the direction of the wire into the paper. For both of these, because the right-hand rule says when I curl around that way, the vector is going to point in. So in both of these cases, the n hat is going to point along the direction of the wire. And so if I have a positive, which I do, it says that the current is flowing along the direction of the wire, right? And because the n hat dot j says this is a positive. So if this is positive, they're both positive, the total current is flowing along the direction of the wire. Since A is greater than B, it says that the total current flowing through A is more than the total current flowing through B, and so it actually says I have to have a smaller negative current flowing out. And so we're going to call this I1, call this I2, and we can say I1 flows into the page, I2 flows out of the page, and furthermore, it doesn't ask this, but we know this, the I1 has to be greater than I2 because the total current still has to be flowing into the page if we add the two together. So there we go. That's what we can tell from that statement there using Ampere's law.